Hello everyone, my name is Tumidan son of Subalan. I am from engineering faculty of UNICEL, University Selangor, and my topic of today's presentation is self-compacting concrete. It's called SCC. The title and content layer with list introduction of SCC, growth and development of SCC, mechanism of achieving self-compaction, material used for SCC, requirement, the test methods, mixed proportioning of SCC, advantages and disadvantages of SCC, uses of SCC, and conclusion of SCC. The introduction of SCC. Self-compacting concrete, which flows under its own weight and doesn't require any external vibration for compacting, has revolutionized concrete placement. Such concrete should have relatively low yield value to ensure high flowability, moderate viscosity to resist segregation and bleeding, and must maintain its homogeneity during transportation, placing and curing to ensure adequate structural performance and long-term durability. Can be defined as fresh concrete which possesses superior flowability under maintenance stability. Example, no segregation, thus allowing self-compaction, that is material conservation without addition of energy. Self-compacting concrete is fluid mixture suitable for placing in structure with reinforcement without vibration, and it helps achieving higher quality of surface finishing. What is SCC? Self-consolidating or self-compacting concrete is highly flowable, deformable, non-segregating concrete that splits and fills in the formwork under its own weight. Stability, avoiding segregation, is increased by using admixture or increasing the number of fine aggregates in the plastic concretes. The third one, SCC has more improved interface between aggregate and cement paste. It increases the strength of concrete. Self-compatibility is plus with high deformability and high segregation resistance. Growth and development of SCC. Third, SCC was first developed to overcome the deficiency of skill and manpower. Subsequently, it's observed that SCC not only reduces the requirement of manpower, but it also results in more durable concrete with the excellent user-friendly characteristics. It has a big role to play because of the sustainable benefits its construction both quantitatively and qualitatively. Research and development into SCC in the UK and Europe are discussed, together with a look at the future for the material in Europe and the rest of the world. Mechanism of achieving self-compaction. Reduction of water-binder ratio, limitation of Ca and maximum size, plus addition of mineral admixture, its high strength segregation resistance of mortar and concrete. Another one, addition of mineral admixture and use of superplasticities and VMA, it's become high deformability of mortar and concrete. The both of is become a self-compacting concrete. These figures are the example of achievement of self-compacting concrete. Figure 1 shows the self-compactly of fresh concrete depends mainly on its ability to flow through obstacle. Figure 2 shows rational mix design method for self-compacting high recommendedly performance concrete. The third figure shows polycarboxylate types of superplasticities. It's suitable for SCC. Comparison of SCC over NC. Ingredients: fines, sand, coarse aggregates, water and admixtures. The normal concrete fines is 12%, sand is 24%, coarse aggregates is 46% and water is 18%. The self-compacting concrete fines shows 18%, sand shows 34%, coarse aggregate shows 28%, water shows 20%, admixture shows 0.01%. Material used for SCC: cement. Ordinary Portland cement of 43 or 53 grade can be used. Aggregates of size to 20 mm. Second is concrete reinforcement. It's 10 to 12 mm. Well-graded cubical or rounded aggregates. Fourth one, FA can be either natural or manufactured and of uniform grade. The fifth one is particle sizes below than 0.125% mm are considered fines. Third one is water. It must be the same quality used for the of RC or pre-stressed concrete. Material used for SCC. The fourth one is mineral admixture. GGBS to improve rheological properties, fly ash to improve the quality and durability, silica fumes to improve mechanical properties, stone powder to increase the powder content. Fifth one is chemical admixture. The new generation superplasticities, termed as polycarbolated, either is particularly used. VMA for stability, air and draining agents to improve freeze-thaw resistance, retarders to control setting time. Requirement of SCC. The main characteristic of SCC are properties in the fresh state. The mixed design is focused on ability to flow under its own weight without vibration, filling ability, and to retain homogeneity, passing ability, without segregation, segregation resistance. A concrete mix can only be classified as SCC if it has above the mentioned characteristic. Different test methods on SCC. Filling ability test, slump flow test, T50 cm slump flow, V-funnel test, pyramid test. And passing ability test are Jeering Test, L-box test, U-box test, and fill box test. Segregation resistance test, V-funnel at T5 minutes, GTN screen stability test. This is the slump flow test, example of the images. It's called T50 slump flow test. T50 centimeter, they will measure the width of the cement. It's under the T50 centimeter, it's not probably SCC. If accurate on 50 centimeter, it was called SCC and is approved by the engineer. This one is V-funnel test. This one is the equipment of the V-funnel. They're using to check the SCC concrete by this V-funnel too. And this Orimet test. This is the equipment of the Orimet test. Jeering test. This is the jeering. It's called jeering, and they measure the cement height by using this test. This is called L-box test. It's an example of the images. And this is U-box test. This is the field box test. Example of images the equipment. And we funnel test at T5 minutes. The test will happen in the 5 minutes only. They calculated the as concrete of durability. Limits of various tests. Slump flow test 650 mm to 800 mm. T 50 cm slump flow 2 second to 5 second. Jeering test 0 to 10 mm. V funnel test 8 second to 12 second. V funnel at T 5 minutes plus 3 seconds. L box test H1 over H2 is equal to 0.80 to 1.0. U box test H1 minus with H2 minus with H1 is equal to 30 mm max. Field box test 90% to 100%. GTM screen stability test 0 to 50%, 15%. Odometer test 0 to 5%. Mixed proportioning of SCC. Ca under below 50%. Water is a powder 0.8 to 1.0. Total paste 400 to 600 kg per meter square cubic. Sand content upper to 40% mortar. Sand below 50% of paste volume. Sand upper 50% by weight of total aggregates. Free water below 200 liter. Paste upper 40% of the volume of the mix. Mix design procedure. First, determine the desired water content. Second, determine the cost aggregate volume. Third, determine the sand content. Fourth, determine the paste content. Fifth, determine the optimum water to powder ratio and superplastiris doses in mortar. The sixth one, finally, the concrete properties are assessed by standard test. Advantages of SCC. The permeability of concrete structures is decreased. SCC enables freedom in designing concrete structures. The SCC construction is faster. The quality of the construction is increased. The problems associated with vibration is eliminated. The concrete is replaced it is, which results in large cost saving. The durability and reliability of the concrete structure is high compared to normal concrete structures. Noise from vibration reduced. This also reduced hand-arm vibration issues. Disadvantages of SCC. There is no globally accepted test standard to undergo SCC mixed design. The cost of construction is costlier than the conventional concrete construction. The use of design mix will require more trial batches and lab tests. The measurement and monitoring must be more precious. The material selection for SCC is more stringent. How economical is SCC? There is a feeling that cost of SCC is much higher than that corresponding normal or high strength concrete. It is seen that the material of SCC is about 10 to 50% higher than NC. If one takes the other component of cost such as cost, compaction, finishing, etc., then one would realize that SCC is certainly not costly concrete for comparable strength. Uses of SCC: draft foundation, pile foundation, complicated reinforcement, repairs and restoration and renewal, retaining walls. This is the major construction using SCC: Bandra Valley Ceiling Project, Delhi Metro Project, Shinkiba Hoasi Bridge, Tarpur Nuclear Power Plant, heavily reinforcement sections, seating benches constructed using SCC. Workability criteria for the fresh SCC. These requirements are to be fulfilled at the time of placing. Likely, changes in workability during transport should be taken into account in production. A measure of the ease by which fresh concrete can be placed and compact is a complex combination as aspect of fluidity, cohesiveness, transportability, ability to compact and stickiness. Third one, the level of fluidity of SCC is governed chiefly by the dosing of the superplasters. Conclusion of SCC. Self-compacting concrete has been described as the most revolutionary development in concrete construction for several decades. Bartos 1998. Originally developed to offset a growing shortage of skilled labor, it has proved beneficial economically because of a number of factors including: first one is a fast construction, and second is suitable for small and large repair jobs, third, reduction in site manpower, fourth, better surface finishes and less finishing works required especially for slab, fifth, easier and higher speed of concrete glazing, sixth, improved durability, seventh, thinner concrete section, 8. Reduced noise levels of absence of vibration, 9. Safer working environment, and last one is shortened period of equipment utilization. Thank you for everyone cooperate and hear my presentation.